Hi there. So let's try to tackle this another easy low-hanging fruit on Leetcode, and it talks about maximum depth of a binary tree. And what it is asking us to do is that he's saying, given a binary tree, find its maximum depth. The maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. A leaf, and he's saying a leaf is a node with no children. So for example, in the example tree here, 15 and 7 are leaves. Now given this binary tree, 3, 9, 20, and then null, null, I guess is 15, 7. This seems to me like more of a pre-order traversal kind of thing. So as you can see, it prints the root, it goes left, then it tries to uh, print, there's like nothing there, so then it goes right, and then it again goes left, and then it goes right. So I think that's what it looks like. But in any case, let's try to do the max depth problem today. Should be fairly easy, and we can use recursion. So what's the idea? Idea is, let's start with the base case, and base case would be if the root is null, then we basically return 0. So if root is none, then we return 0. Now otherwise we return 1 plus max. So what is going on here? Let's try to take a look. So imagine you are at any point in time in your recursion, in the depth or the abyss of the recursion, if you would like to call it that way. You would see that imagine you are at 15, you're working on the root node 20. What would happen is you would try to treat that as the whole tree itself, and then you would say, let's take the depth on the right, and then you take the depth on the left, and then you take the, every time you can go one level down, you have to add 1, of course, and then at that point you say the max of the either the left side or the right side. So you have to call max on max depth. Now this is root dot left, and the max of root dot left and root dot right. So that should do it. But what is the intuition behind it? Intuition is very simple. Basically all we are doing is we are recursing down the left and the right side on each root, each node, and then we are basically culling the half that is less. So we are only interested in the half that is higher. And if you continue to do that, you would see that, imagine now you come at 3, you would see that the one side would have given us 2 and other side would have given us 3. So 1, so that would be, so now here it will be 1, it will be 2, and then for 3 we'll get 1. So 1 plus, for example, in this case, it would, this would will evaluate to 1, and this would evaluate to 2 because 20 and 7, and then 1 plus max of 1 and 2 would have given you 2, and 1 plus 2 would be 3, and that was why the answer would have been 3. So let's try to run this code and see if it works. So we have a problem, and the problem is that in Python you have to, for the member function, you have to use self to say that, yeah, it does belong to our class. Otherwise it would think you are trying to refer to some global function max depth and which is not defined. So let's try to run it now. Well, that has passed, that has been accepted. So let's try to now submit and see if we can pass other test cases as well. Awesome. So basically we have, it says it's faster than 52.85% of Python the online submissions. The test case has passed. And but what is the lesson I would say from these kind of problems is that to be able to use recursion well, and the recursion usually the mistakes that we make is, for example, we might forget to add a base case, because without the base case the recursion becomes infinite and there's no way for it to basically get out of the recursion. So that is very important, and if you keep track of those things, it should be fairly easy. But on the other hand, also we have to make sure that when you, in this case for example, we had to do a max on the left and the right, because we kind of keep throwing away the side that's smaller. I think those are the two takeaway I would say from this problem. Otherwise it sounds fairly easy. And so from next time we might try to do the minimum depth or the balanced binary tree and some of these other problems. I mean, trees are definitely fascinating creatures in the flora and fauna of data structures. So I would definitely give a fairly good amount of time to revise the tree problems for the interviews. I've seen them being asked very regularly. Sometimes they would ask you things like, and try to not use recursion. They might ask you, hey, do a label order traversal, or don't use recursion. Try to find the height of a tree or the depth of a tree without using recursion. Then you may have to use, for example, the techniques, for example, enqueuing and dequeuing, and I think those are the techniques that people use for label order traversal of the trees. But all those things we can talk in the later videos. For now, I am wishing you all the very best in your coding practice. See you next time. Bye bye.